Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, you all know that in chemistry we were discussing the chapter chemical reactions and equations, right? Now let's go for continuing this, and remember this is 7th period of this chapter. In the previous period we learned different types of chemical reactions. Then first, once we shall recall all these types of chemical reactions. What are the main types of chemical reactions? Let's tell one by one. First one is, it is combination reaction, right? Second one is decomposition reaction. Third one is displacement reaction. Fourth one is double displacement reaction. And fifth one is, it is redox reaction. In addition with these, even we have also come across the different subtypes of chemical reactions. Just to recall these also, yes, they are. The first one is, it is endothermic reaction, right? Next one is exothermic reaction. Then after that, we come across the different types of decomposition reaction. So what do you call the decomposition reaction? Which is carried out by providing heat. It is thermal decomposition. In the presence of sunlight, it is photolysis. Photolysis is also called photochemical reaction. And what do you call the decomposition reaction which is carried out by passing electricity? It is called electrolysis. Then after that, even we come across some other subtypes. They are precipitate reaction, right? Similarly, neutralization reaction. Then one more, 8th one, oxidation reaction. Then 9th one, it is reduction reaction. So these are the different types of chemical reactions which we come across in this chapter. Then do you know what we are going to learn in today's class? It is all about the common effects of oxidation. That is, these common effects we come across in our day-to-day life. Then what are these? When you go for taking the unused metals like iron bar, iron pipe, then copper plate or copper wire, then silver metals, what will be your observation? So there you can see the brown coating or the brown patches on the iron metals. Then the green patches can be seen on the copper metals, and also the black or greyish black, that patches can be seen on silver metal. Then what do you call these? They are nothing but corrosion. Got it? This is the first effect of oxidation. Then what is the other one? It is related to food item. There are some food items, when they are exposed to the atmosphere, then or when they are kept open, then you can see after a long time you can experience that they lose their taste, and also the bad smell will be coming. And it is also one of the effect of oxidation, and we call this as rancidity. So these are the two important common effects of oxidation. Common effects of oxidation. What are these? Yes, one is, it is corrosion, and second one is, it is rancidity. Then what is corrosion and what is rancidity? Let's go for learning this. Suppose you go for taking an iron nail, then you just rub it with a sandpaper. Then could you tell what will be the color of the iron nail? It is silvery grey. And keep it on the terrace for about 4 to 5 days. Then observe that. What will be your observation? You can notice that there will be the brown patches or brown coating on the iron. Then this is known as corrosion of iron or rusting of iron. Then how to define corrosion? Initially, when you measure the mass of the iron and similarly, then when it is get corroded, again you just remove that and again measure its mass. So there will be difference. So it loses its mass after the corrosion. So it is due to the action of the moist air, the action of the iron metal with the moist air. Likewise, so in general, metals are eaten up by the action of air, moisture or some of the chemicals on their surface. This is known as corrosion. Clear? The process of eating up of metals by the action of air, moisture and the chemicals on their surface is known as corrosion. So then we say that corrosion of iron, corrosion of copper, corrosion of silver. But particularly with respect to iron, we call that corrosion as rusting of iron. Then you all may be thinking that what is rust? Here, observe. When iron nail or when iron metal reacts with oxygen present in the air and also water vapors present in the air, then it develops the brown patches on its surface, and this will be Fe2O3X H2O, and this is called rust. And the chemical name of this rust is hydrated iron oxide. Once I repeat, it is hydrated iron oxide. Then how do you define rust? Once I tell that, listen carefully. When iron reacts with oxygen and water vapors present in the atmosphere in general, when it reacts with the moisture, then it produces the brown patches on its surface, and this is known as rust. Got it? Then how to protect the iron metal from the rust? From the rust, I'll go for giving you that information. Before that, let me write the definition of corrosion. Observe, here I have written the definition of corrosion. Then these are the examples. Corrosion of iron, it is hydrated iron oxide. So if the chemical equation with respect to this can be written like this: Fe plus O2 plus X H2O gives rise to, it is Fe2O3 X H2O. Next, similarly, second one, corrosion of copper. That is, when the copper metal, when you go for taking the copper metal which has been unused for a longer time, then there you can observe the green coating. It is the combination of copper carbonate and copper hydroxide. Then how is it formed? Here, let me tell you that. So when the copper metal is exposed to the atmosphere for a longer time, then it reacts with oxygen, water as well as carbon dioxide present in the atmosphere, and it gives the green material which is the combination of CuCO3, copper carbonate, plus CuOH twice. You can also write like this. Then similarly, corrosion of silver. Well, silver, when it is exposed to the atmosphere, it reacts with sulfur present in the atmosphere and produces the compound called silver sulfide, which is blackish gray, whereas this is green, this is brown. And I have already told you that among the corrosion of the metals, for corrosion of iron, we call it as rusting. Got it? Rusting is nothing but the process of eating up of iron metal when it is exposed to the atmosphere. that is called rusting of iron. Then here we use the word rust. Then what is rust? Rust is when the iron metal is exposed to the atmosphere, it reacts with moisture and produces the brown color flasky like substance on its surface. That is known as rust. Clear? I am going to write the definition. Okay. Here, when iron metal is kept in the atmosphere for a considerable time, then it reacts with moisture and produces a red brown flasky substance and this is known as or called rust. And the chemical formula of rust is Fe2O3X H2O. This is also called hydrated iron oxide. Yes, dear students. So now you are going to copy from here. Common effects of oxidation, write these two. Then write the definition of corrosion, and these are the example, and write about rust. Then afterwards we will move on to another concept, that is how to avoid the metals from rusting. Dear students, now let us come to know how to prevent iron metal from rusting. Here I write prevention of iron from rusting. Yes, the first one is by painting the metal. So you can go for preventing the iron from rusting. Next, second one is by galvanizing. Then what are these two? Painting. We know that in the paint oil content will be there. So therefore, when by applying the paint to the iron metal, it avoids the contact of moisture with the iron, so that it does not get corroded or it doesn't get rusted. Similarly, galvanizing. It is nothing but electroplating of iron metal with zinc. We will go for using zinc, and this will be used in earthing. Galvanized iron is used in earthing. And third one is by greasing. By applying the grease also, we can go for making the iron metal to keep away from the rusting. How? We know that in grease also there will be oil content. So by applying that, so it will avoid the contact of iron metal with the moisture. Clear? Yes. Now we are moving to the next part of this chapter. Okay, dear students, now let us come to know what are the conditions under which iron get rusted. Here are right. Conditions under which iron get rusted. So for that we have two simple activities. Just keep observing them. Here I am going to take 3 test tubes, and you can name these test tubes as A, B and C. A, B and C. Then you take 3 iron nails, rub them with a sandpaper. Then after that, keep an iron nail in the test tube A, another iron nail in the test tube B, and one more iron nail in the test tube C. Next, In first one, you just put some crystals of calcium chloride. Then close its mouth with a rubber cork. Similarly, then here in the test tube B, add water such that the iron nails should sink in that. Then put some drops of oil. Then again close its mouth with a rubber cork. Next, third one. Now you go for again pouring the water in the test tube C such that iron nail should immerse in that partially. Then close its mouth with a rubber cork. Got it? Then leave them for few days, about 3 to 4 days. Then take out remove the rubber cork. Then take out the iron nail from each test tube. What will be your observation? You will observe that in the iron nail which is kept in the test tube A, there will be no change. It will be as it is. Similarly, in B also no change. Whereas in C, so there you can see the red-brown patches. So then can we say that this iron, that is iron nail which is kept in the test tube C, get rusted? Yes. Then how do you come to know the conditions under which iron get rusted? Very simple. Look here. In the first case, iron nail is kept in A, test tube A. So here what is present inside the test tube? It is A. Then you all may be thinking that then why we are using the calcium carbonate crystal? It absorbs the water vapors present in the A. Clear? Whereas in this case, second one, so it is immersed in water and we have put some drops of oil. What is the reason? Here we are making the iron nail to react with only water, right? Here air is there, here water is there. By putting the oil, we can avoid the contact of air with iron nail. Clear? Whereas in third case, iron nail is immersed partially in the water. Here air is there as well as water is there. Clear? Only among these three cases, only in case of C, iron get rusted. That means we can come to know that iron undergoes rusting under two conditions. One is in the presence of air and second one is in the presence of water. Clear? So here I'll write. First one is in the presence of air, nothing but oxygen. Second one is in the presence of water. So these are the two conditions. Got it? Yes. Now we'll move on to the next part of this chapter. Dear students, I have already told you another important common effects of oxidation. It is rancidity. Then when do you say a food get rancidity or rancid? Yes. There are some food items which contain fats and oil. When they are exposed to the atmosphere, then they produce the unpleasant smell and they lose their taste, and we call this condition as rancidity. Got it? Yes. We can define the rancidity as, here I'll write the definition. Yes. This is the definition. When the food item containing fats and oil is exposed to the atmosphere, it produces the unpleasant smell and loses its taste, and this condition of the food is known as rancidity. Then how to prevent the food items containing fat and oil from the development of rancidity? See, Dear students, you are also very familiar with this. We will go for using some of the food items containing fat and oil. They are to be stored in the packets, and these packets are filled with the nitrogen gas. Got it? And also we will go for storing the food items in the airtight container, and we will go for keeping the food items in the refrigerator, right? Even by adding antioxidants also, we can prevent the food items from the development of rancidity. So these are the ways from which we can prevent the food from the development of rancidity. Here I use the word antioxidants. Antioxidants. Then what are these? These are the substances which prevent the food from rancidity. Here I write a substance which prevents the food item containing fat and oil food from the development of rancidity is called antioxidant. Then we have two important antioxidants. They are, one is BHA and another one is BHT. So BHA is butylated hydroxyanisole, whereas BHT it is butylated hydroxytoluene. Clear? Yes. Here I will go for writing the how we can go for preventing the food item from the development of rancidity. How? First one, by adding antioxidants to the food item. Then by keeping the food items in the airtight containers. Then third one, by storing the food items in the refrigerator. Similarly, by packing the food items, that is food items containing fats and oil items with nitrogen gas. Yes, these are the ways from which food items can be prevented from rancidity. Yes, with this the chapter has been completed, but now we are going to write the answer for the questions that are given in your textbook, NCERT textbook. The blue questions will be there and also exercise questions will be there. Let's go for answering. Yes, please go for writing from there to here. Let's copy this. Dear students, now let's move on to answering for the questions that are given in page number 10 in NCERT textbook. They are given in blue color. The first question is like this. A solution of a substance X is used for whitewashing. Here they are given, name the substance X and write its formula. Second one, write the reaction of the substance X named in first and above with water. Did you understand? Observe it. Solution of a substance X is used for whitewashing. Could you tell which substance is used for whitewashing? There is no doubt. This is calcium hydroxide solution, is it not? But solution of which substance is calcium hydroxide? It is calcium oxide, right? When calcium oxide reacts with water and produces the compound called calcium hydroxide. Hence, we can write answer for first one as X is calcium oxide, and its chemical formula is CaO. And we also know that calcium oxide is also called quicklime. Clear up? Next, second one. See, write the reaction of the substance X named in the first above with the water. That is, the substance X is CaO, which is quicklime. When it reacts with water and produces a compound called calcium hydroxide, that is CaOH twice. Clear up? CaO, it is quicklime, and this is water, and CaOH twice, it is slaked lime, also called calcium hydroxide. Now, let's move on to second question. Observe this. Why is the amount of gas collected in one of the test tubes double the amount of gas collected in the other? In which process? It is in electrolysis, right? Electrolysis of water, is it not? And name the gas. Dear students, you all know that in the electrolysis of water, water gets split up into hydrogen and oxygen by passing electricity, is it not? And we also know that water contains two molecules of hydrogen, that is, two atoms of hydrogen and one atom of oxygen. Hence, these gases will be collected in the test tube. Here, hydrogen, it is two atoms. Hence, the gas collected in one of the test tube will be double of the other. Did you understand? Yes, let me go for writing the answer. So, observe this. So, we all know that during the electrolysis of water, that is, when electricity is passed through water, it gets split up into hydrogen and oxygen gases, right? Then we also know that water contains two parts of hydrogen and one part of oxygen. Since hydrogen is collected in one test tube and oxygen is collected in another test tube, therefore the amount of gas collected in one test tube is double of the other. Did you understand? Yes. Please go for copying from here to here. Let's copy this. Okay, dear students, now let's move on to answer the questions that are given in page number 30. Go through first one. Why does the color of copper sulfate solution change when iron nail is dipped in it? We know that color of the copper sulfate is sky blue, right? CuSO4. When it is aqueous. When iron nail is dipped in that, what happens? As iron is more reactive than copper, it displaces copper from copper sulfate and produces a green color solution called FeSO4. Then copper gets separated. That is, on the iron nail there will be brown coating, which is nothing but copper. Clear? So here I'll write. So here, when iron nail is dipped in copper sulfate solution, it displaces copper from its solution, forming iron sulfate and copper, because iron is more reactive than copper. Clear? Then after that you can write this chemical equation. Next, observe. Give an example of a double displacement reaction other than one given in the activity 1.10. So now let's go through the activity that is 1.10. It has been given like this. It is Na2SO4 sodium sulfate plus barium chloride BaCl2 gives rise to what it is? It is NaCl plus BaSO4, where BaSO4 is precipitate. Okay, other than this we have to give another example. Here I'll write the example. You may take PbNO3 twice. Lead aqueous solution of lead nitrate. It reacts with aqueous solution of potassium iodide and produces, it is potassium nitrate and lead iodide. You can write PbI2 lead iodide, which is precipitate, plus potassium iodide KNO3. It should be balanced by yourself only. Next I will take one more example. PbNO3 twice plus HCl. So how can we go for writing this? It is PbCl2, right, lead chloride plus HNO3. Clear? This is also an example for double displacement reaction. So next, let's move on to third one. I'll take one more example. It is Na2CO3. What it is? Sodium carbonate. Then CaCl2. This is calcium chloride. The aqueous solutions of these two react with each other to form calcium carbonate CaCO3 plus NaCl. So please balance the equations yourself. Now observe third one. It is identify the substances that are oxidized and the substances that are reduced in the following equations. We are very familiar with the substances that are oxidized, whether it is oxidizing agent or reducing agent. It is reducing agent, right? And the substances that are reduced, it is oxidizing agent. So now we are going to identify these. Let's go for answering. Look here. In first one, sodium reacts with oxygen to produce sodium oxide. First I'll write substance oxidized. Substance oxidized. Which substance will gain the oxygen? Here, sodium. So we can write Na. Then substance reduced. Substance reduced is, it is oxygen. Clear? It is with respect to first one. And second one, next, substance oxidized. We know that here hydrogen is the substance which removes oxygen from copper oxide and get oxidizes to water. Hence, this is substance oxidized, H2. And substance reduced. What is the substance reduced? Copper oxide get reduced to copper. Hence, we can write CuO. Clear? Yes. Now, please go for copying from there to here. After that, we will go for answering for the questions that are given in exercise. Okay, now let's move on to answer the questions given in exercises. This is the first question. Observe this. Which of the following statements about the reaction below are incorrect? Please do remember. Observe it. Here the given reaction is 2PbO, which is solid, plus carbon solid, gives rise to 2Pb solid plus carbon dioxide solid. That means when lead oxide reacts with carbon, produces lead and carbon dioxide. Here are the options. Lead is getting reduced. Is it right? Dear students, we know that the substance which contains oxygen or which is ready to give oxygen for oxidation is called oxidizing agent. So PbO is oxidizing agent. So it gets reduced to lead, Pb. Got it? Next, the substance which removes the oxygen from the oxidizing agent, that is called reducing agent. Here C is a reducing agent, and this get oxidizes to carbon dioxide. That means it takes oxygen from lead oxide and becomes carbon dioxide. Here the question is, lead is getting reduced. Is it right? No. Why? We know that lead oxide is getting reduced to lead. Next, carbon dioxide is getting oxidized. No. Here carbon will get oxygen from the lead oxide, then it oxidizes to carbon dioxide. This is incorrect. Then carbon is getting oxidized. Yes, certainly. Carbon will take oxygen and becomes carbon dioxide. It is getting oxidized. Then lead oxide is getting reduced. Certainly. These two are right. But what has been given? Which of the following statements about the reaction below are incorrect? Which are incorrect? A and B. Hence, our answer should be the first one, that is A and B. Clear? Yes. Now, let's move on to second one. Don't copy. First observe here. Fe2O3 ferric oxide plus aluminium gives rise to aluminium oxide plus iron. Here, iron gets separated from iron oxide, right? Why? Because aluminium is more reactive than iron. Hence, it displaces iron from iron oxide. Clear? Now, you just go for this. It is the above reaction is an example of whether it is combination. No, because in case of combination, two or more reactants combine chemically to form single substance. Then double displacement. Here ions are not getting exchanged mutually, so it doesn't come. Decomposition reaction. Here a single substance gets split up into two or more substances, but here it is not. Then what about displacement? A chemical reaction in which an element present in the compound is displaced by another element which is more reactive. Here aluminium is more reactive than iron, therefore it displaces iron from iron oxide. Hence this option is correct. What should be our answer? Option D. This is displacement reaction. Now let's move on to third question. Please go through this. What happens when dilute HCl is added to iron filings? Tick the correct answer. Before going to those options, just once we shall go for recalling the equation. Here I'll write, observe. What happens when dilute HCl is added to iron filings? Here iron filings, HCl gives rise to, what happens here? Here FeCl2 plus hydrogen gas is liberated. Is it not? Now see that. Option A. Hydrogen gas and iron chloride are produced. Right? Then chlorine gas and iron hydroxide are produced. Will not come. No reaction takes place. Here actually a reaction takes place because metals react with acid. Iron salt and water are produced. No, because it is not a neutralization reaction. So first option is right. Clear up? Here I'll write. For answering once we shall go for writing the equation, it will be easier. Fe plus HCl gives rise to FeCl2 plus H2. We can write this as 2. Then option A is correct. That is hydrogen gas and iron chloride are produced. Iron chloride are produced. Next, we will move on to fourth one. Observe fourth one. Question is, what is balanced chemical equation? What is balanced chemical equation? The chemical equation in which the number of atoms of each element on the reactant side is equal to the number of atoms of each element on the product side. Right? Here I'll go for writing the answer for first sub question. The chemical equation in which the number of atoms of each element on the reactant side is equal to the number of atoms of each element on the product side is called balanced chemical equation. Right? Now, sub question. Why should chemical equation be balanced? Why it is? Dear students, you know that in any chemical reaction, the mass of the reactant, total mass of the reactants will be equal to total mass of product. Is it not? So, this is possible from the law of combination called, yes, what it is? It states that mass can neither be created nor be destroyed in a chemical reaction. Hence, so it has to satisfy the law of conservation of mass. We can write because in order to satisfy the law of conservation of mass, which states that, what is the statement? Yes, it is mass can neither be created nor destroyed in a chemical reaction. Which means, what is the meaning of that? It is the mass of reactants is equal to the mass of products. Clear? Yes. Please go for copying from there to here. Afterwards, we will move on to next question. Dear students, observe this fifth one. It is, translate the following statements into chemical equations and balance them. First one, hydrogen gas combines with nitrogen to form ammonia. See that hydrogen reacts with nitrogen to form ammonia. You are all very familiar with the chemical formula of all these. Hydrogen, how do you write? Very good. It is H2 plus nitrogen, this is N2. Ammonia, this is NH3. Then go for balancing it. See that we will go for taking a compound having maximum number of atoms. This is NH3. In that element having maximum number of atoms, it is hydrogen. Right? It is 3. And here hydrogen 2. How do you balance? So it should be multiplied by 2 and this should be multiplied by 3. Here I'll write balanced chemical equation is 3H2 plus N2 gives rise to 2NH3, right? See that 3 is there, we have multiplied 2, 2 3s are 6, here 3 2s are. Whereas nitrogen, 2 atoms of nitrogen, it is balanced. Next B1. Let us translate the second equation. Chemical reaction, it is hydrogen sulfide. Hydrogen sulfide gas burns in air to give water and sulfur dioxide. Hydrogen sulfide, how do you write? Very good, it is H2S. It burns in air. When it burns in air, obviously it reacts with oxygen. Is it not? To produce what? Water and sulfur dioxide. Water, H2O plus sulfur dioxide. It is SO2. Now which is to be balanced? See that hydrogen 2 atoms, here 2 atoms. Oxygen, here 2, but here 3. Now we have to balance oxygen only, is it not? Look here. Here hydrogen, sulfur, oxygen, hydrogen 2, oxygen 1, sulfur 1, oxygen 2. Whereas in this side, hydrogen it is 2, oxygen it is 1, sulfur 1, oxygen plus 2. These two are balanced already. Only the left thing is this. How do you go for this? Here 2, if you go for taking 2 here, and here also we should put 2, because look here, if you put here 2 here, 2 2s are 4 atoms of oxygen, here 2, here 1 will be there, hence we have to put 2, right? Then 2 2s are 4 hydrogen, there is 2, hence we have to put here 2. Then 2 atoms of sulfur won't come. Then how to go for that? Let me explain. Yes, I'll write the balanced equation. See that here oxygen is distributed to 2 compounds. Hence I am going to equalize these. Hence it should be multiplied by 2. Here I'll write 2. Once I write H2S plus O2 gives rise to H2O plus SO2. Balanced chemical equation. Look here, 2 should be multiplied here, 2. Now see that 2 atoms of oxygen. Then here 2. If it is 2, 4. But here 2 are there. How do you go for balancing? Here I'll take 3. If I take 3 here, then hydrogen 2 2s are 4. Here it should be 2. 2 atoms of sulfur. Here 2. Understood? Now see that 2 2s are 4. 4 atoms of hydrogen. Here 4. Sulfur 2. Here 2. Oxygen 3 2s are 6. Here 2. 2 2s are 4. 2 plus 4 6. Hope that you have understood. First I have taken 2 here. Then after that hydrogen will be unbalanced. 2 2s are 4 here. Only 2 are there. Hence I put 2. Then I balanced sulfur. Yes, this is. Next we shall move on to C1. Here barium chloride reacts with aluminium sulfate. Barium chloride BaCl2 plus aluminium sulfate Al2SO4 tries to give what? Aluminium chloride and precipitate of barium sulfate. Aluminium chloride, it is AlCl3 plus barium sulfate BaSO4. Let's go for balancing it. Here also we have to take the elements that are involved: barium, chlorine, aluminium, sulfur, oxygen. On the left hand side Number of atoms. Barium 1, chlorine 1, aluminium 2, sulfur 3, oxygen 4 3s are 12. Whereas in the RHS side, barium 1 balanced, chlorine it is 3 unbalanced, aluminium 1 unbalanced, sulfur 1 unbalanced, and oxygen it is 4. Then which element has maximum number of atoms? It is oxygen, 12. Hence we shall go for balancing it. So 4 should be multiplied by 3. I'll go for writing the here balanced chemical equation. It is BaCl2 plus Al2SO4 thrice gives rise to, here I'll write AlCl3 plus BaSO4. Okay. On the right side, oxygen should be multiplied by 3. Here, 3. Observe. Now, oxygen is balanced. What about barium? Barium, 3 atoms of barium. Here only 1, hence I'll write 3. Clear? Next, chlorine, 3 2s are 6. But chlorine here, it is 3, hence it should be multiplied by 2. Aluminium 2, here already 2. Once you check that, 3 atoms of barium, 3 atoms of barium. 3 2s are 6, 6 atoms of chlorine, 2 3s are 6. Next, aluminium 2, sulfur 3, oxygen 3 4s are 12, then 3 4s are 12. So it is balanced chemical equation. Now we are moving to D1. Observe this. Potassium metal reacts with water. Very vigorous reaction takes place because potassium is highly reactive metal. Potassium reacts with water to produce what? Obviously, potassium hydroxide and hydrogen gas. So, potassium hydroxide, KOH plus H2. Whether the equation is balanced? No. Here, because 3 atoms of hydrogen, here 2 atoms. Here I'll write K, potassium, hydrogen, oxygen. Potassium 1, hydrogen 2, oxygen 1. RHS side, potassium 1, hydrogen 1 plus 2. Then oxygen only 1. So hydrogen is not balanced. Let's go for balancing. Here again I'll write balanced chemical equation. K plus H2O gives rise to KOH plus H2. Here hydrogen is not balanced, hence it should be multiplied by 2. On the RHS side, here 2. Now 2 atoms of potassium, here 2. Oxygen 2, but here is 1, hence 2. Next, hydrogen, 2 2s are 4. Here 2 hydrogen, 2 hydrogen, hence it is balanced. Clear? Hope that you have understood. See, this type question is very important in the examination point of view. You have to practice all this. Do one thing, before copying this, try to convert these chemical reactions into equations, then go for balancing them. After balancing, check whether your balanced equations are correct or not by observing these. Let's go for that. Dear students, hope that you have written this. Yes, and we have few more questions from 6 to 20. Nearly, yes, still 15 questions are there. So let us go for answering them in tomorrow's class. Okay, today what we have done, they are important. Please do practice them today itself. Don't keep anything pending. We are not at all leaving any concepts from the text. We are covering each and everything, but only the thing is you have to practice it well. Okay, yes, let us conclude the class. Thank you very much.